It's nice to wake up, grab a coffee, open your laptop, and start working inside your own private security lab. But what if you're not home? What if you're traveling and have to use someone else's laptop or just your phone? If you take security seriously, you can't depend on one machine in one location. You need your lab running 24/7, always available from anywhere. In this video, I'll show you how to build your own cloud-based cybersecurity lab on a remote server. Install Kali Linux, set up the essential tools, and make it secure and accessible from anywhere in the world and any device. This is my personal cybersecurity lab. It's not on this laptop or on my home network. It's running in the cloud 24/7 with Kali and all the tools I need. If my laptop dies, I can even borrow a friend's phone and still have full access to it, no matter where I am. That's the beauty of having everything in the cloud. To build this, we need a VPS that lets us deploy Kali Linux directly. This isn't a sponsored video, but I personally use Hostinger for my servers, and I do have an affiliate link in the description. If you decide to use it, I earn a small commission, which helps support the channel and allows me to keep making videos like this at no extra cost to you. For this setup, I'm using the KVM2 plan. It's powerful enough to run our lab comfortably, but if your budget allows, you can always choose a higher plan. The 24-month option usually gives you the lowest monthly cost and best overall value, also a free domain, but the 12-month plan is fine as well. Pricing can vary depending on your location and applicable taxes, but no matter which plan you choose, using the code SOFTSWEB at checkout will get an additional 10% discount. Now for the best part. When selecting the operating system, choose Kali Linux directly from this list, click Confirm, and then Continue. Create an account, complete the payment, and after a few moments, you'll have a brand new cloud server with Kali Linux installed and ready to use. From the dashboard, you'll immediately see your new VPS. You can also find it by clicking the left menu, and now copy the IP address assigned to it. Now open any local terminal on your computer. I'm using Linux, and this is the default terminal. On Windows, open Command Prompt or PowerShell. And if you're on Mac, the built-in terminal app works great. Let's log into our cloud lab using this SSH command and the password you set during the setup. So this is what the server looks like right after we log in. Let me zoom out so you can see it more clearly. What you're seeing here is just the default message. It basically tells us that this is a minimal installation, which is exactly what we want for a cloud lab. Nothing unnecessary is installed yet, which means we have a clean environment to work with and full control over what gets added. This is actually a good thing when you're building a security lab, because instead of starting with a huge system full of tools you may never use, you can install only the things you actually need for learning and testing. As you see, this is a cloud image. Kali provides special builds for cloud servers, which are optimized to run well on servers' infrastructure. So this system is already prepared to run efficiently on the server we just deployed. Now use this command to quickly verify the system information. It prints information about the operating system, the kernel version, and the architecture of the machine. The next thing to do is to update the system with this command. Even though this is a brand new server, the packages included in the base image might not be completely up to date. Security tools, libraries, and system components are updated frequently, so keeping the system updated is very important. This process might take a minute or two, so I'll speed up the video for you. Before we start installing tools, let's talk about how we actually access the server, because the way you log into your server is one of the most important security decisions you can make. First, run this command to get rid of that message we saw on the first login, and later we'll replace it with something else. Until now, we logged in using a password, but passwords are not the most secure way to access a server. A much better way is using SSH key, which works using a pair of cryptographic keys. One key is private and stays on your computer. The other key is public and gets placed on the server. The server checks if the connecting user has the matching private key, and if it matches the stored public key, access is granted. This method is significantly more secure than passwords. Now exit the server and generate a new key locally with this command. I'm using the ED25519 algorithm, which is a modern and secure standard for authentication. I'm also give it a custom name so it's easy to identify later. Now create a passphrase for the private key. Even if someone somehow gets access to the file, they still cannot use it without the passphrase. Now we need to copy the public key and place it on the server. we'll log back into the server one more time using the password so we can install the public key. We need to create these directories and give them appropriate permissions. And finally, to paste the public key inside the authorized keys file, make sure you copy it and paste it there, then press Ctrl+X and hit yes to save. Now that the public key is installed, we can exit the server. And now, instead of using a password, we authenticate using our private key. The server now asks for the passphrase creating during key setup, and once we enter it, we're logged in. If you want to add an extra layer of security, the password authentication can be disabled completely. This means the only way to access the server will be through your private key. For doing so, open this configuration file, scroll down until you find password authentication and set to no. Save this file and restart the SSH. Now the only way to access the server is using your key. Now for the fun part, installing our security testing tools. We'll start with Nmap, one of the most popular tools in the cybersecurity world. At its core, Nmap helps you see what's running on a machine and figure out what's visible on the network. It's the kind of tool that's useful whether you're doing a security audit or just trying to get a clearer picture of your infrastructure. But be careful when using Nmap, because it is a very powerful tool. You should never run scans against IP addresses that you do not own or do not have explicit permission to test. Always make sure you are working inside an environment that belongs to you or where you are authorized to perform security testing. For this demonstration, I'll simply use the same server. This simulates the behavior of checking a server from the outside. So I'll open a new terminal, connect to the VPS again through SSH, and start a simple Python web server on port 8080 using this command. I'll leave this terminal visible so you can clearly see what is happening on the server side. Now let's scan localhost using Nmap. This means we are analyzing services running on this same server. And as expected, Nmap detects that port 8080 is open and also identifies that a simple HTTP server is running using Python. But Nmap can do much more than scanning a single port. We can use it to scan the entire system and see every service that is listening on any port. Here we can see that port 22 is open and port 8080 is open. Port 22 is the SSH service we are using to log into the server, and port 8080 is the Python web server we just started. In a real security assessment, this is usually the first step. You identify open ports, understand what services are exposed, and then evaluate whether those services are properly secured. Next, let's use another security testing tool called Nikto, which focuses specifically on web servers and checks them for common misconfigurations, outdated software, and known security issues. So I'll run Nikto against the same local web server we started earlier on port 8080. As the scan starts, Nikto detects that there is a Python server and then it begins testing the web server for common security issues. Here it reports missing security headers like X-frame options and X-content type options. These headers help protect web applications against certain browser-based attacks. It also checks for things like outdated software versions and directories that might expose sensitive files. In total, Nikto sends thousands of test requests and reports potential issues it discovers. And just like with Nmap, this type of testing should only be done on systems you own or have permission to analyze. For the next tool, we'll use another very well-known security testing framework called Metasploit. The installation is quite large and takes a few minutes, so I'll speed up this part. Once installed, we can quickly confirm the version of the framework. Now let's start the Metasploit console. When the framework launches, it loads its modules and prepares the environment. And as you can see here, Metasploit includes thousands of modules that can be used for different types of security testing. Inside the console, we can search for modules related to specific services. Once we found the module, we have to load it. And then we configure the target we want to analyze, which will be the same as before on our local host, and then run the module. And as expected, the framework connects to the service and identifies the HTTP server running on that port with the exact version, and the same for the Python. And this demonstrates how frameworks like Metasploit can be used to gather information about services running on a system. And just like with the other tools we use today, this type of testing should only be performed on systems you own or have permission to analyze. So in this video, I only showed you 3 tools, but that's already enough to give you a feel for how to start using your new VPS cybersecurity lab. I've prepared a PDF you can download for free from the link in the description, which includes 50 essential Kali Linux tools you can use, along with explanations and example commands. It covers tools for network scanning, web testing, OSINT, password auditing, and more. I recommend grabbing it and keeping it as a quick reference while practicing in your own lab. Thanks for watching and see you next time.